It separates candidates who write SQL only for reading from those who understand database mutations, Writeback CTE mechanics, and data integrity constraints. It evaluates risk awareness. Preventing silent data loss is a critical senior trait. This is a classic database maintenance problem. You have a table with duplicate records. Same email address, different primary keys. The goal is simple. Write a query to delete all duplicate emails, keeping only one unique entry. Let me show you why naive solutions fail, why candidates silently destroy their databases under pressure, and how to write a production-safe cleanup script. Most candidates immediately reach for select distinct. It makes sense. The query runs, and the output is clean. But here is the trap. Distinct only cleans the result set of this query. It does not touch the physical table. The duplicate rows are still sitting on disk. The moment the interviewer pivots and asks you to write a delete query to physically clean up the table, the select distinct mental model completely collapses. Let us trace why this is so hard under pressure. Candidates have a cognitive blind spot. They view SQL as a read-only query layer. When forced to delete, they face a knowledge gap about CTE writeback and row-level selection. Under pressure, they write a delete query with a nested subquery using group by and having. This query runs successfully, but it deletes ALL rows for duplicate emails, including the copy you wanted to keep. The database is now silently corrupted. The production-safe pattern is a three-tier strategy. First, use a CTE with row W_number to partition the data by email and order by ID. This assigns sequential numbers starting at 1 for each duplicate group. Second, use CTE writeback semantics. We can execute a delete statement directly against the CTE. By filtering where the row number is greater than 1, we keep the oldest record and physically delete the duplicate rows on disk in a single pass. Watch your parameters. If you partition by id instead of email, every row gets ranked as 1, and nothing is deleted. Always partition by the business key. Also, ensure your order by matches the survival rule. If the rule is keep the oldest, order by id ascending. If the rule is keep the newest, order by id ascending. Without explicit ordering, the ranking is non-deterministic and can delete the wrong row. Lock this rule in when deduplicating tables. Follow the three-tier rule. First, detect duplicates using group by and having. Second, identify which specific instances to delete by using row W_number. Third, remove the duplicates using CTE writeback and deleting where the rank is greater than 1. Avoid naive IN subqueries to protect your database from accidental data loss. Let's analyze the select distinct output-only approach. Time complexity, O of n log n. Space complexity, O of n. Requires sorting. Only cleans query output, does not modify physical tables. Fails database cleanup contracts. Let's analyze the group by plus having detection-only approach. Time complexity, O of n log n. Space complexity, O of n. Performs aggregate sorting. Useful for finding duplicate keys, but cannot identify which specific row instances to keep. Let's analyze the row_number CTE plus delete optimal approach. Time complexity, O of n log n. Space complexity, O of n. Single table scan with window sorting. Safely isolates duplicate row instances and deletes them in a single pass writeback transaction. The interviewer will then ask, how do you keep the row with the lowest ID for each duplicate group? Use order by IDASC inside the row_number window function. The row with the lowest ID gets RN equals 1 and survives, while higher IDs get RN greater than 1 and are deleted. The interviewer will then ask, what if two rows are identical across all columns, including the primary key, no ID to differentiate? Without a unique row identifier, a single pass delete cannot target specific duplicates. The standard production pattern is Copy select distinct rows to a temp table, truncate the target table, and insert the rows back from the temp table. The interviewer will then ask, how would you deduplicate without window functions? Use a self-join delete. Delete P1 from person P1 inner join, person P2, where P1.email equals P2.email and P1.id greater than P2.id. This compares every row with all other matches, deleting the one with the higher ID